Good afternoon. On behalf of Prime Construction and my team, I would like to thank you for this opportunity to present our design concept report for the Valencia Road Reconstruction Project. The designs we produced for this corridor has been a fantastic opportunity to exhibit our strengths as both individuals and as a unit. Now, without further ado, allow me to begin by introducing the fine engineers that made up this team. Starting with myself, my name is Eugene and I'm the project manager.
Hello everybody, my name is Ryan and I'm the hydraulic lead.
Hello, my name is Jose and I'm the structural lead.
We'll be representing Prime Construction and presenting on our design concept report for the Valencia Road Improvement Project. This all was a culmination of efforts and could not have been done with the following bright engineers: Marwan Sami as roadway lead, Ethan Harper acting as both traffic lead and vice project manager, Alex Martinez responsible for geotechnical and pavement design, Valerie Gonzalez as our environmental lead, and lastly, Cesar Maldonado and Ruin Zhang both acting as our construction leads. Now that we have introduced ourselves and the team, allow me to talk about our goals for this project. The City of Tucson Department of Transportation has hired us for professional consulting seeking to research a multidisciplinary design to reconstruct and improve Valencia Road from Old Vale Road to Atterbury Wash. The purposes of this improvement effort are to increase roadway capacity, reduce accident rates, and further the options of accessibility for commuters. This is all to alleviate concerns such as lack of multimodal services and stormwater flooding issues in nearby basins, all of which consequentially summing up to a failure in meeting the serviceability and safety expectations for the ever-growing community. This presentation is made with the purpose to discuss how our design plans to accomplish this goal and touch on these issues in the Valencia Road corridor.
Now I would like to take a few minutes to talk about the roadway report completed by Marwan Sami. The overall width of the right-of-way for this project is 150 feet, and the width of the typical section is 113 feet. In the western direction of travel, the proposed roadway improvements include the addition of 12-foot driving lanes, 6-foot multi-use bike paths, 10-foot paved AG paths, 6-foot EG paths. In the eastern direction of travel, the proposed roadway improvement include the addition of 12-foot driving lanes, 6-foot multi-use bike paths, and a 6-foot sidewalk. The design also includes a curved median of 20 foot in width.
In regards to the level of services with our design, I'll be moving on to a traffic report that was completed by Ethan Harper. These are the results from the simulation model ran in Bistro. With these results, we think it still is the best option to stick with 4-lane divided roadway, sacrificing the movements during the peak of day. The 6-lane option will provide a roadway that is underutilized throughout the majority of the design life. Looking at the results on the AM feature peaks at Old Vale, we see a failing intersection that can be focused in on a failing movement. With a delay of roughly 134 seconds per vehicle headed westbound, the 6-lane option might be considered. Looking at the AM values for Nexus Road, we see the overall delay equivalent to a LOS of C, whilst the PM values at Old Vale provide another issue, with the failing movement being the heavy traffic coming eastbound at the end of the day. But the intersection still operates at a LOS of C. The PM values at Nexus are handled well, with only the northbound right turn having issues with a concerning LOS of E. The intersection itself is still projected to operate at a LOS of C.
Thank you, Eugene. Now I'd like to discuss with everyone the drainage report. So what you're reviewing on this slide is a watershed map for Area 1 of our project. The 7 subbasins to the north comprise a total area of 91 acres, and they produce a peak discharge of 340 cubic feet per second, daylighting near Pantano Road. In order to handle this offsite flow rate, a variable shotcrete line trapezoidal channel will be routed parallel to Valencia Road along the length of the corridor. The proposed roadway expansion will require the installation of storm drainage pipe networks and 36 drainage inlets as well. What you're reviewing on this slide is a watershed map of area number 2, Atterbury Wash. The area of this watershed is 4.5 square miles with a peak discharge of 1,462 cubic feet per second. This flow concentrates at 8 10-foot by 4-foot reinforced concrete box culverts that convey the water underneath Valencia Road. We recommend extending the existing culverts and replicating the current plunge basin at the outlet of the new system for protection and energy dissipation. Now let's discuss the geotechnical report that was completed by Alex Martinez. For geotechnical and pavement considerations, we focused on the existing aspects of the project soil and used that information to make logical recommendations. We first analyzed the site conditions at the surface and subsurface level to get a full overview of the project soil. We then use that information to provide general geotechnical design considerations that would have a substantial impact on the project. Based on our understanding of the soil underlying this project, we designed pavement structures that would be exclusive for the project roadway. Lastly, we also provided recommended earthwork that would need to be executed to accommodate for proposed design changes made by Prime Construction.
Thank you, Ryan. Now I'm going to discuss the structural report that I completed. The main structural component for the Valencia Road Improvement Plan is located 1,700 feet east of the Valencia Road and South Elton Road intersection within the southeastern section of Tucson. The current structure cannot support the development of the Atterbury Wash sector. Therefore, 3 alternative structures were considered for selection and design. Alternative 1 was a single-span bridge using bolt T-girders. Alternative 2 was a double-span bridge using AASHTO Type 2 girders. And our third option consisted of a 42-foot extension to the existing 8-cell box culvert. Prime Construction weighed the pros and cons of each option through a comprehensive comparison as displayed in this table. The extension of the reinforced concrete box culvert has the lowest cost, did not require any roadway elevation changes, included structural components that were easily obtained through local means, had the fastest construction process, and the least environmental impact while retaining adequate water flow, making it our recommended choice at a price of $1.71 million.
Now let's discuss the environmental report that was completed by Valerie Gonzalez. So here at Prime Construction, we use the Envision program to measure the sustainability of our work through all the phases of all of our projects. Envision has 64 credits and is split into 5 categories. These are quality of life, leadership, resource allocation, natural world, and climate and risk. Our goal for any project we do is to attain a gold level of sustainability, which requires a minimum of 353 points. We accomplished this goal by receiving 367 of the 882 total points. The categories that we have had most success in earning points in are quality of life, leadership, and resource allocations.
Thank you, Ryan. Of course, no project design can be complete without discussing the budgeting schedule. The preliminary cost estimate for this project for the 4-lane section is $33 million, with the greatest portions of the allocated resource being roadway, site preparation, and roadside work. This cost estimate includes contingencies such as events that are unexpected, as well as allowances for certain activities without an exact quantity, such as landscaping. And lastly, miscellaneous items like stormwater prevention plans, quality control, surveying, and maintenance and protection of traffic. A phased approach is proposed to perform work that will allow constructability of the scope of work. The scope of work can be divided into 3 phases, with the first 2 being able to be performed at the same time, 1A and 1B. 1A consists of main items to site preparation, temporary lines, roadway and roadside work from on Valencia Road to Pantana Road to Oldvale Road. Phase 1B is consistent of main activities including site preparation and culvert extension on Valencia Road at Atterbury Wash. And lastly, Phase 2 will have main work items including those of Phase 1A, but performed on Valencia Road from Oldvale Road to Nexus Road. With that, thank you so much for listening to our presentation. We hope that with this project and its further development, we will be able to lead to a safer community and a better Tucson. Thank you.